talk about some legacy stuff. Anyway, as you can see, most of my slides are in handwriting, so because first of all I find it to be an awfully zen experience to kind of write things down and present them in an odd way, but also because I'm a software engineer and I'd really rather have my code talking and the code of others talking, and the code is the kind of the basis of all arguments. There's nothing else but code out there. I love libraries, I love tools, I love helping people, empowering people to do more things, and so I found myself a place somewhere in the tool development, somewhere in the framework development world. Okay, enough about me. I would just like to know a little bit about you. How many of you consider yourselves developers? Software developers. Okay, DEVCLUB lives up to its name. Excellent. How many of you are Java developers? Okay, cool. Okay, excellent. So some of the code I'll show you won't be too unfamiliar, I hope.
Excuse me, where have you been in 2014?
Okay. In 2013 to 2014, I was actually working a couple of houses building that way in Kühnel-Nagel. I was building desktop application core essentially there. But then I came back to Playtech to work with some other another kind of a stack, I suppose.
They came to this office?
Yes, exactly. Then I came to this office. Not too far to go. Okay, cool. A little bit about today. So we'll be having a short, okay, maybe a bit lengthier overview of the philosophy of Tapestry. I'm not going to go too much into detail how to exactly build web applications with Tapestry. I don't expect you to start building stuff with Tapestry right after this presentation, and if you really wish to, then I urge you to consider it a couple of times. But Tapestry has its place. Tapestry tends to think of itself as a general purpose framework. I would say it's less general and more purpose. There's not too much, there aren't too many patterns in Tapestry that would work for every kind of a possible use case. So I'll be talking a little bit about the philosophy, a little bit about the context, that is what made us kind of drive towards Tapestry, and also based on all of this, we will have a look at some experiences, some war stories. I will show you some of my scars figuratively, and also a lot of positive stories. And I urge you to ask questions anytime you want, so that's completely okay. All right, so first, a little look into the history. I won't bother you too much with some details, but just to know where we come from and where Tapestry comes from. So Tapestry as a project started around year 2000 or so. The man was called Howard Lewis Shipp. Howard Lewis Shipp was a developer at some kind of a company, and besides his main work, he started working on this new thing, this new application that was inspired by Apple's web objects. If any one of you know web objects, then you might have like a rough clue what it's about. But web objects is now considered dead completely. So yes, this was just recently, and. Around 2002, Tapestry got to its first version. 2004, eventually it got into the Jakarta project, which is, if you know, the Apache is kind of a set of useful tools for building applications, and eventually, at around 2006, Tapestry was elected as the top-level project in Apache, so meaning it's now 10 years since Apache has been a top-level, Tapestry has been a top-level Apache project. And then from 2008, we see the latest and I suppose the greatest version, the 5.0, develop. So it's been developing for 8 years now. We're somewhere around 5.4. So you kind of see a bit of a slowdown. There are a few reasons for that. Maybe we'll come to them as well. And okay, so a little bit about the kind of a concept behind Tapestry. So Tapestry is more of a user-oriented framework. So it's a web framework in which you have these basic building blocks. You have a page. A page consists of multiple components. Components may have so-called mix-ins, and all of this might be supported by services on the side. So Tapestry's folks themselves think of this as a kind of an MVC or model view controller pattern where the components are essentially the view part and the page is sort of a model and controller put together. So essentially like not a single responsibility principle, but dual responsibility principle, or I don't know, DERP, if you may.
Like AngularJS.
Yes, like AngularJS. That's a good example. It's somewhat like AngularJS. It's somewhat like Vaadin, if you're familiar with Vaadin or GWT. I don't think of it quite this way. I rather think of the services as a model, and maybe the page and the components, maybe the page as more of a view model thing, and components as rather the view portions of the whole picture. So, by the way, these slides are actually color coded. So everything that's black is the closest approximation to fact that I could give you. Kind of everything that's blue are my opinions. Everything that's everything that's green are Tapestry's opinions or the Tapestry developers' opinions. Everything that's orange is narrative, and everything that's a different shade of orange is also narrative, because I was I don't know, colorblind at the moment when I made the slides. But never mind. So the basic building blocks: pages, components, mix-ins, and services. And there's a lot of events. So Tapestry doesn't handle web requests the same way you would usually imagine a model view controller type of a thing handling requests. So you don't map requests to something. You rather use HTTP to call events, to trigger events on the application. So when a GET or a POST request comes into the application itself, it's a servlet 3.0 or 2 point something application onto which a specific filter is applied. And essentially, when there's a whole chain of command of dispatchers and the chain of command of request handlers that eventually take this request and make an event out of it, and then they fire this event in your application, and based on what you return from the event handler. So this is also a kind of a unique concept, I suppose, or a weird concept, that event handlers return something. And when event handlers return something in Tapestry, this is something that gets somehow returned to the user. So, for example, yes?
Does it all happen synchronously?
It all happens within a single thread, yes, for one request. Okay. Right. So thread per request. And all of this happens synchronously. Eventually, when a result is returned from the event handler, then a chain of result processors again works with the result and tries to bring you something useful out of all this mess. Okay, never mind that. Time for a live demo. As you've been seeing, this weird thing I'm showing slides on is actually an application itself. It's a Tapestry application. And just because I don't do PowerPoint, or I don't know, for reasons. But anyway, let's have a look into what's going on and what an application is made of. So let's take an example page. So we have this lovely page. This is from Tapestry's sample application. So if you take Tapestry's homepage, Tapestry Apache org, you generate the Maven archetype Tapestry example, then you will get this kind of a roughly similar page. The sample application shows you just some of the features. So let's say, for example, there's There are some navigation tricks here, some weird Ajax examples and whatnot. But let's have a look at what exactly does this page look like. So we have a demo index here. I hope, oh Lord, can you see the code? Who can't see the code?
You can enter presentation mode also.
Okay, let's try to see where it.
View.
Thank you. Let's see if this is. Alrighty. Okay. Now I want to see less hands. Who can see the code now?
See the code.
Okay. Who cannot see the code right now? Sorry. Okay. Excellent. That's very, very nice. All right. So we have this thing called a template. So these are Tapestry essentially gives you a certain standard layout for things. It says that templates, they have an extension of TML. They actually are they look like HTML. They're XHTML or XML, whichever way you want to think about them. But the point is that templates are not handled like you would handle sort of dumb templates, or templates aren't something that are just bunch of characters into which you replace things. So it's not like Velocity. It's more a more different style. So the idea is that when Tapestry actually loads the template, it loads a whole page object model from this template, and this gets, first of all, the template gets parsed, and there are specific classes for that, so I can show them as well. But the idea is that the whole template is parsed. It has to be valid XML. This brings on a bunch of other delicate problems you see sometimes with compared to HTML, or let's say a bit more like HTML. So this is one part. The other part is to note is that there are lots of there are some custom elements. So for example, something like t-action link. There are elements like loops, like if statements. Don't have a good example here, but the thing to bring with you is the idea that most of the elements you see here either are HTML elements, or they have like some kind of a representation in Tapestry's component library. So for example, an action link is actually an action link component. For example, loops and ifs, they're actually Tapestry components. And you can build your own classes that loop or do some conditional parsing. And then there's also kind of an idea that you can use a component to represent a specific element on the page. So for example, HTML t-type layout says that there's actually a layout component, a component called layout, into which some other content is rendered. And there's a schema which just defines a certain number of additional elements, things like comments or containing elements which don't have a direct representation in the component world. Okay. All right. So usually, what happens first when a template is loaded? There's a Sax-based parser. So if you know the Sax API, Tapestry uses Sax to parse a template, and the template itself is then made into kind of a page model. The page model is eventually rendered. So rendering is also a kind of a different trick. So we don't. There's no like. There's no direct dependency between the characters you see here and whatever gets put into your output. So what happens is that internally, this here, the template itself, is translated into this set of page objects, and these page objects, each of them render in a queue, and they push the render command, so-called render commands, into a render queue, and render queue then essentially does all the rendering. So it's a slightly different way of thinking about things, and the one thing to take away from here is also that most of this happens in memory. So Tapestry doesn't scale. Yeah, sorry.
This rendering happens on client side or server side?
It happens on server side. So most of it is server side. There are some Ajax features in Tapestry, but they're kind of put in there later, so they don't feel too natural for a developer to use. But the idea is that that the whole rendering happens on server side. The rendering is done in memory, and again, it's not done directly, so the components themselves don't render into a parse into a character buffer directly, but they rather render into a markup, into a DOM element representation in memory, and then eventually this gets written into a print writer. So if you kind of think of it, then usually the process that's usually quite simple, rendering of a template, is something that's relatively tricky in Tapestry and relatively long. And this often takes most of your request time as well. So this is something you have to kind of work with and understand how it works, and why it takes the time, why it takes the memory.
Does it mean that it renders everything on every request?
It renders everything on every request. Yes, if you do like a full page request, but you can also do smaller like section or so-called zone requests, which can be delivered via Ajax. Essentially, as a short JSON snippet which contains the The parsing is luckily done only once, so it wasn't too much of a performance problem by itself, the SAX itself. There's a whole lot of other performance bottlenecks there could be, but SAX luckily is quite well optimized there, so it's not that bad. It's not really that bad. Somebody else, yeah?
So when it renders, it returns images to the client side, or just shows in the page?
Images.
And how does it render? It renders elements?
It renders just the HTML, right? So it's rendering in terms of just HTML output. So for example, if I'll take some kind of the page itself, you'll just see HTML. There's not much to it. It's a bit of a bit optimized. So let's say it throws away some of the white space and so on. But it renders HTML. Okay. All right, let's look at the page class itself. So we have, for every template, we also have a page class to work with. Page is now the dual responsibility thing, essentially the thing that that works both as a request handler and as a controller, and as a rendering bit. So page classes are essentially, they look like simple beans. They look like simple classes, but there's a lot of sort of inherent magic going on behind the scenes. So pages, components, mixins, they're all treated specially. They're modified quite heavily when they're loaded. So there are custom class loaders in Tapestry that take your code. For example, if you have an inject, so let's say you want to inject a service into the page, then this inject gets turned into something, some specific bytecode by a thing called Inject Worker, and for many of the annotations you can use here, there are specific workers that essentially write bytecode into your class. you can inject properties, you can inject different symbols, you can inject other pages, other components, and yep, you guessed it, inject is also a custom annotation of Tapestry. So Tapestry provides its own inversion of control container. Tapestry doesn't rely directly on top of Juice or Spring. You can use them, you can hook them into the Tapestry's IOC container as well, but Tapestry provides its own annotations for you to use. Mixins are now slightly different. Mixins are something that don't have a template themselves, but rather can modify the render phases of components. So you can modify what happens before the component renders, what happens after the component renders, and they sort of provide this additional features or additional functionality around the whole rendering pipeline, as we saw before. Internally, for example, to see these events, there are a few ways you can kind of handle events. There are method name conventions, so things like onActivate means that there's an activate event coming from somewhere. Activate is actually the event that gets triggered when a page is rendered first or when a page is loaded. There are events like onAction from learn more, meaning that it's when an action event is triggered from a component which has the ID of learn more. But there are specific annotations to override it as well to make it actually readable, because this thing here isn't exactly too well refactorable. Let's say you change the ID, you should change the component's ID on your template, and suddenly your event handlers don't fire anymore. So something to keep in mind usually. There's a lot of functionality to guarantee that you can play or juggle around with your kind of native types. So, for instance, if you like to use your own custom beans, your own custom bean types, there are specific features called value encoders, which deal with kind of let's say two-string and from string operations. Deal with those, but with your own custom code provided, so that you don't actually have to implement toString to do something business-like. There's an interesting system called type coercion system, where the idea is that if you have some kind of data and you want to get this data in another, let's say, class, you want to make a string out of an integer, then there's a service into which so-called coercion tuples are provided. And these custom coercion tuples essentially provide you a path to move from one type to another. So let's say somewhere, for example, in the database configuration. Just an old legacy, but it was a problem that essentially wasn't too well resolvable with Tapestry's own features, or with Tapestry's coercion tuples. The reason why I can talk to you about later. Right now, I just don't want to waste too much time on that, but heavy modification when they're loaded, and usually when you see, for example, you use some kind of fields on a page, you can also have your own custom fields here, let's say private fields, and the private fields get reset every time the page object loads. So internally, you see this class here. It's like a normal class. It's as if it has state. It's as if it has some kind of fields, some kind of properties that are persistent in memory. But in reality, you essentially write effect. Yep.
Request, but there's some kind of a state across the
Absolutely. There's a whole lot of different ways you can maintain state there. I will talk about these different states and different ways of maintaining state just a little bit later. But yes, the to the page, but every time a request comes in, a new thread is allocated, and a new set of per thread values is allocated for that page. In a short run, but first of all, let me just give you a little bit of information about the context, like the context in which we kind of started thinking about a new back office solution. So, what is IMS? IMS, or the Information Management Solution, as we call it for long, so is a solution which manages the center, which is kind of the central hub of every gaming site. Every gaming site we provide. There's an IMS in there. There's a set of services which aren't usually gaming related. Things like regular customer management, customer communication, and so on. And there's a sort of a boundary layer of party talks to. So, for example, when a player plays some games or some different gaming system has activity and it needs to talk to us, it goes through the so-called gateways. And the IMS itself is a set of essentially RESTful services, but there's a couple of services which we call the backend. So don't be alarmed by the name. So actually, what we call the backend is actually the admin, or the back office admin systems, the ones that actually have a front end. So everything that's called backend has actually a front end, and everything we call front end, meaning the gateways, meaning these services, they're kind of actually the back end. So it's a bit odd. But we love this terminology because it's fun and it's special. And there's a big database everywhere, so everything is integrated mostly through a database within a single IMS site. And these backends actually have a direct connection to the database as well. And the backends are the things that our admins, our operators use. And this is roughly what a back. This isn't what the average operator sees. This is something that a super admin sees, but an average operator has maybe some. I suppose there's a lot of features. Overall, we've been building this kind of a thing for the last 16 years or so, and there's a lot of things that we had to face. First of all, was that we had a lot of developers. But we didn't have too many UI developers. So there was maybe like a single UI. So what we saw was that we needed some kind of a framework that feels homely, feels natural to a system developer as well. Let's call them system developers. It's not too good to kind of put people into groups, but this is what one of our problems was. And also we had this kind of knowledge gap, I suppose. We had a lot of Java developers who were also relatively good at doing database stuff. We had PHP developers, in which most of our backend was written in. who were also, some of them were also good database developers. There was like movement from one place to the other, but there wasn't really too many people deal with both UI things, user experience things, and with system development at the same time. So we knew that whatever solution we chose, we knew that there would be a learning curve, so why not pick Tapestry, which has a learning curve of a brick wall, essentially. And there was essentially a ton of, metric ton of UI features of these pages and so on. I've brought a number here. The number actually reflects now the present day. So we roughly have about 800 pages in the UI. So there's about 800 pages that the operators use. If these pages were like a big novel, sort of every page is a new page, and you know there's a specific feature for that page, then we probably wouldn't have any other choice but to kind of brute force through things. But the fact is that out of these 800 pages are actually maybe 200 4-page essays when we think of literature. We have features that look similar, that behave similarly, but are clumped into these few-page groups. So things like I don't know, things like player management, things like maybe campaign management, whatnot. So we knew we had repetitive things. We knew our UI wasn't too dedicated for data entry. So these 800 pages are not like completely data entry pages, and I don't know, aren't heavily used pages, but most of them are some kind of reports, some kind of quick reaction pages. So most of the user's workflow was actually kind of observe and react to things. And this is was that okay? Maybe we can have developers actually just produce the components. Maybe we can just let the developers produce the components from which somebody else can build the UI. So let's say you build a component that's a generic search component, and you build there's let's say a player here. Let's now build a UI for managing players, and then the admin would kind of take the UI composer, say that okay, there's a search here, do this on players. There's an edit form here. When the user clicks on a player, then open the edit form and go from there. Well, with 800 pages or so, this didn't quite pan out the way we hoped. So this was pretty much because the Excellent. That's a really good question. So admins is a very generic term here. So it's administrators. We can call them product operations specialists. We can call them maybe super users of a specific site and so on. It on the exact use case, and let's say there are people who actually have the permission to create such pages. So a very let's have developers produce both components and pages, and then let the so-called admins or the super users just configure them. So the idea was that we already had components that were able to function with each other. And what we hope to gain a lot was the sort of productivity when creating such pages. So the idea was that let's reuse our components, let's share our component libraries, and let's build pages from these smaller atomic components. What we needed for that was also some kind of an information next to the model itself, the domain itself, to see, to kind of help us build this interactivity with less code. And what we went with is essentially the idea that we have components, and that we have, next to our model, we have a lot of meta information. So it comes in forms of annotations, in forms of, for example, some additional classes, some additional configuration. But essentially something that provides information about the model, saying, okay, what kind of types we have here, what kind of criteria these types we need to match to, what kind of searching capabilities they have. So, for example, a player could be searchable by its username. So it's okay to search a player by username, but not okay to search a player by password. So something like this. Okay, well, you don't need to specifically say that don't search players by password, but you get the drift. And pages include these components. And what we got eventually, as a result, was that we were able to use Tapestry, use the kind of component-oriented way of thinking. Oh, wow, this page looks awesome. Anyway, the resolution is lovely. But what we got to is essentially that we, for example, have a page, generic search page for players. There's actually about up to about maybe 100 filters here that the players can be sought by, depending on users' permissions. And then there's, let's say, for example, search results with that look similar in every kind of a use case. So when a user comes to a page, he sees the old familiar search form, and he can use it without any kind of relearning how it exactly works for players, or how it exactly works for something else. And what we got eventually was that the template for such a page, hundreds of filters, all sorts of different search features, was, let's say, roughly 50 lines of code of Java glue in the page class itself, and about 450 lines of code of meta information in the model. So the 450 plus is something that can be reused. So, for example, if we take another kind of a page, again, a player search, a slightly different search, but using the same components, using the same model, but just configured slightly differently. And what we went with was this sort of smart. Oh, yeah, sorry.
Components can also represent or visualize some data.
So in the kind of the backendish side of things, we use Hibernate. So we use Hibernate to actually do the queries themselves. The model contains slight alterations to the way database acts as well. So we build upon Oracle database, so we can add some additional performance features, let's say, that are Oracle implementation specific. But essentially, the idea is that behind this table or behind this search, there's a real Hibernate entity, and this Hibernate entity is what the whole search framework works upon.
Okay, so long story short, these components are smart enough to first prepare the entire query, then pass it on to data access layer,
Yeah.
and then
Yes, true. And we built kind of out-of-box work with each other that brings to the table component or something like that, or from a form component to something else. There are a lot of drawbacks. So persistence is one of the things we saw as a drawback for Tapestry. So there are a lot of different ways you can persist data over requests. So sometimes you need to sometimes you just need to keep some of the data alive for the user session. What we saw with sessions is that they essentially are a kind of a scalability risk. You can very easily say that a field should be persisted. You can just add persist annotation. That's it. But what happens is that you get a session key for every user in this case, in server's memory or wherever you persist the sessions. Tapestry also provides client persistence, which is kind of iffy. It only can be used in specific scenarios when you're doing posting. Usually, client persistence doesn't scale so well over use cases. There are special kinds of session persistences like Flash, which is kind of a session persistence that just is persisted over one request. There's a specific scenarios where this can be used. There's a conversation persistence which comes with different plugins. And but the bottom line here is that if you can avoid persistence, you'd better. So there's not too much else to say. That if you can work without server-side state, then better do so. The other endless horror is using this fun combination of when you have form state actually somewhere, when you have validation, when you want to use Ajax, when you want to use dynamic forms. So, for example, forms into which user can add rows or can do something with it. A fun way how Tapestry stores things that need to be done when form is posted is actually in this one big hidden value. It's called tform data. Tform data is base64 serialized object stream. So essentially, when form renders, the form writes all the actions it wants to do into this kind of a big blob. It gets sent to the user side, and then it gets submitted with the form. And that's an
Cannot do some horrible things.
Yes, absolutely. Until version 5.3.6 of Tapestry, it wasn't even validated. So it pretty much, you could write essentially Java classes here that would run on server side. That's absolutely amazing. This is one thing I would redesign right now. What they've done to alleviate this is that they've added HMAC signing here. So somewhere in that data is, I think, an HMAC signature. But yes, it was a risk. It was a risk we had to work around of a little bit to make sure that the clients couldn't actually post some weird code, or not to give a client a user interface for doing DOS attacks essentially. So this was pretty much the biggest concern with Tapestry 5.3 and earlier, that this was a source of DOS attacks. This was a source of problems. If you wanted to add, let's say, something into the form, a new line, you would need to serialize its form actions as well, and you couldn't do it in this. You couldn't kind of modify this on client side. So you would need to go all through all sorts of different hoops to get this data there, to get this thing running.
So the client can still check the code, but it has to be signing.
Yeah, essentially, yes, the client has to. I'm not 100% sure actually how it's persisted on server sides, but I think with every request, maybe the HMAC signature is also stored. So if you can fake the signature, then yes, you can have fun with it. Things are getting better. Unfortunately, Tapestry isn't getting any more popular, but things are getting better. In Tapestry 5.4, we already see modular JavaScript. What used to be the case was that if you included JavaScript libraries, JavaScript codes, then this was all serialized into the page as a big blob of JavaScript. So which wasn't exactly too too friendly with if you had dependencies within JavaScript itself, like you didn't know which part of which JavaScript executed first. Nowadays they're adding support for require.js and modularizing it, so it's getting a bit better. Tapestry was always redirect after post and redirect after event request, so every time you clicked a link there were actually two requests. So first request handled the event, the second request handled the re-render of the page. So they fixed this a little bit, so if you had a form error, for instance, you don't have a redirect anymore there. So you see a slightly uglier URL, but you're at least not putting load on the server. Nowadays there's also Bootstrap included, and one of the moves they did was to start using Plastic instead of JavaSys for the code generation and class modification. Plastic is essentially based on CGlib, I think, and it's also an internal Tapestry project. So they moved from a framework that wasn't really well maintained to something they had under their own control, their own API, sort of, let's say, for these modifications. And the sample application was much nicer, has become much nicer. But altogether, okay. So should I use Tapestry for something? The slide or the chart, which doesn't have units nor scale. So not really a chart, but okay. So the idea is that the thing to take with you. Tapestry is really good if you have the time and the money to spend for this initial kind of burst of development. The idea that you have to do quite a lot of work before you can actually start being productive. So if you have this initial investment to go with, then that's fine. I put IMS-ish things somewhere there, so things that have essentially repetitive usage patterns, repetitive building patterns. These tend to go cheaper over time, and we see this a lot with actually the way we can reduce the amount of code that we write. But for most of your if you're a startup, if you're trying to do a visual showcase, showing what you can do and all sorts of fancy features, then I wouldn't recommend it. I wouldn't recommend it for simple things like blogging or your first prototype of your application. So don't go there. For functional showcases, for showcases when you go business side first, business features first, it works really well. I think you can really get your application running quickly if you don't care too much about how it looks. But styling Tapestry tends to be a slightly bigger endeavor.
So what's your comment on the tagline was codeless? Something?
Yes, exactly. Codeless something something.
What's your comment on that? Like, where does it deliver more?
Codeless in terms of you need less code. You need to think more. That's the problem.
Like considering the brick wall that you did.
Yeah. Okay.
How do you need to spend 10 years before you get to the codeless?
Okay. So. It depends very much on your specific use case. For us, it was the brick wall took, I think, about 2 years to climb. So it was a wall. It was a steep wall, but luckily we knew what we wanted. So essentially, we saw the light at the end of the wall or at the top of the wall, and we knew that if we climb there, then we will get the productivity. Of course, you can get like features rolling immediately, and Tapestry 5 sort of tries to at least boast itself for its backwards compatibility. Before Tapestry 5, this was. Don't go there. Backwards compatibility wasn't a thing then.
But considering what you told us about like how horrible and how you must avoid so many features of it, like what other systems did you evaluate, and what were the features that this won with?
Okay, so there were quite a lot of frameworks. I mean, I maybe painted a really horrible picture of the thing, but I painted a horrible picture because I just want to warn you. There's a lot of positive things you can take with you, and a lot of positive things that you can use there. But back then, the main frameworks we considered were also mainly component-oriented, because we knew that we wanted to go with an approach that we have reusable components. Meaning Apache Wicket, Apache, I think Struts was one of them. Not sure if Struts was component-oriented, but I think we definitely tried it out. This was maybe, unfortunately for us, slightly bad timing, because we started looking at things around 2007, 2008, and then at 2009, pretty much the web framework development world kind of leaped off, and you saw things like Rails and things like, I don't know, Vaadin becoming a thing, GWT and so on. But back then, you know, there were a few things. We saw that Tapestry had the most potential for us, and I believe for us it definitely delivered more, but this might not be the case for everyone, and this is just maybe like a bit of a warning, or a bit of a journey into the unknown in let's say on an average case or on a usual case.
So another question I had, because you showed that backend, front-end, whatever world with the gateways, and you mentioned APIs, and based on based on kind of the template you showed, it looked like it was this old style, like HTML only, and nowadays the world is with like mobile views and kind of APIs generated from the same same server. Is there some support for kind of delivering different views of the same data?
Delivering different views, roughly maybe on the level that Bootstrap allows you to.
What do you call it, different formats, in the sense of like an Excel view versus an HTML table, or an API, JSON API with the same logic?
I believe the question is that the same view model, so-called, can it serve different types of views, like JSON, rather HTML, JSON?
I see what you mean. Okay. Short answer, no. Long answer, no. The thing is, the template kind of acts as the structure of what you're trying to build, and this is one of the main concerns why it doesn't feel like an MVC framework. There's no controller, there's no direct control. You can serve JSON and you can serve requests, but these have to happen, let's say, separately, and you can do it with the same page, with the same view model, but not based on the same template and not naturally. So you can turn data into JSON and so on, and we've been doing this as well quite a lot, depending on specific features. It's not a natural way. The same way, for example, it's natural for Grails to do so.
Question regarding JSON. Do you use the same template engine to render JSON?
The same template engine as in Tapestry, you mean? Or?
Yeah.
There's no. I wouldn't say it's a template engine. The problem is that it's not a template engine. It doesn't render templates the way the usual kind of a template engine would work.
Yeah, it kind of does interpolate some business logic.
Yeah, it does. Okay, the way we do it is we use pretty much the built-in capabilities Tapestry provides. So it has its own JSON API and it has its own JSON kind of features for doing so, but they're not related to the template. So I think this is also one of the maybe problems or confusion cases for Tapestry, that the template seems as if it's a picture of the web application itself, and it seems as if it's the HTML, while Tapestry doesn't really think of it as the HTML, or it doesn't think of it as the content that will be provided to the user, but rather as the structure. So I've imagined that you can do Tapestry without the HTML, and you can do Tapestry with something like, you can build swing hierarchies from Tapestry's templates if you want to, really. And it kind of works the other way around. At least that's a feeling for me personally. Okay, thank you very much. We're a bit over time, so sorry about that. But yeah, thanks for listening.